Hi everyone, welcome to our webinar. I will wait another minute for people to join and then we can get started. Okay, I think we waited long enough. So let's get started. Two housekeeping items before I start with the actual presentation. One, you can ask questions through a Zoom Q&A button. I will try to answer as many as I can after each section and probably at the end, but not during. Second, the session will be recorded. So if you have an emergency, you can leave. I actually wouldn't know about it and can watch the recording later. So today webinar, how development team or data team can cut cost or reduce cost with ScyllaDB. And let's start with a quick poll. Where are you on your NoSQL adoption? I will give you a few seconds to answer. And in the meantime, let me introduce myself. I'm VP Product at ScyllaDB. And before that, I was product manager in Oracle. And even before that, in the telecom domain. And even before that, I was a developer. And as you can see, this picture was taken a few years back. So what are we going to cover today? First, I'm going to quickly introduce what is ScyllaDB and where is ScyllaDB in the great landscape of NoSQL databases. Second, I'm going to cover why ScyllaDB is less expensive or even can increase revenues. Second part or third part will be how is ScyllaDB less expensive? So what make it less expensive? What make it a higher performance, low latency database? The next section, if we have time, is a unique feature in ScyllaDB called workload prioritization that can help you balance latency and throughput between workloads. And last, a summary and a few more data points. So with that, let's introduce Scylla. So ScyllaDB is a NoSQL database. And there are many. I will enhance on that a little bit later. The company exists for almost 10 years. The two founders, Avi and Dor, have a background in hypervisor and kernel development. And the database itself is focused on performance. I will enhance on that in much details very soon, in particular throughput, latency, etc. The database comes in three main variants. One is open source. You can go to GitHub, download the code. It's mostly in C++. Compile it if you have some time on your hand, or just download the binary and use the open source version, as many users do. Second is an enterprise version. It's a closed source version of the database, mostly, and I would say 95% identical to the open source, but with some extra features. Some around security, some around performance, and I will cover one or two of them toward the end of this session. And last but not least is Scylla Cloud. Scylla Cloud is our SaaS service. Like all other vendors, a software vendor out there, we have a SaaS or database as a service. For our perspective, or for this call, the SaaS is identical to the enterprise. It's run the same binary as the enterprise. Of course, it's wrap it up with administration and management and such. But the core database, which we're focusing on this session, is the same. Scylla is compatible with two other popular database. One is Apache Cassandra, and the data API there called CQL, Cassandra Query Language. The second one is Amazon DynamoDB, and the API there is a REST-based. So if you have an application that use either Apache Cassandra or Amazon DynamoDB, you can just switch the endpoint or the IP and start working with Scylla or Scylla Cloud. And maybe I will touch on that later on the driver if we have time. A quick list of some of our users and customers. So you can pick the one that is closer to you from domain perspective. We have many. I quickly want to map where Scylla sits in the great landscape of NoSQL database. So first, it's in the NoSQL domain. There is a relational database, NoSQL database, and other databases. Scylla is a NoSQL database. And if we're looking at the pretty old by now CAP theorem, is on the availability side, meaning that it's a prefer availability over consistency. Actually, Scylla, like Cassandra and other DynamoDB, have what's called tunable consistency, where you can control the consistency per session. Later, by the way, a theorem that enhance the CAP theorem talk about not just availability versus consistency, but also compare latency without failure. So if you look at this kind of mapping, Scylla is on the low latency side. From data modeling perspective, again, Scylla is similar to Cassandra, Amazon, HBase. All of them are, you can think about them as a key value data structure, or if you sometimes it's called a wide column or other names, which I found confusing. Other database, of course, and this is not all the option in NoSQL. There is time series database and there is other databases. Just to map Scylla, it's eventual consistent database in a wide column store data format. And this is another attempt to map all NoSQL database that I liked, and I give you the source here. You can see here that this person map Scylla as a key value, the wide column, and a time series, and true that Scylla can act as any one of those. Scylla is a distributed database, and it's distributed in a sense that it's not just some databases are distributed inside a rack or in a local zone. In Scylla, it's very often that you use a globally distributed deployment with what we call data center in different regions. You can think about it as Amazon region or AWS region or Google region. Of course, we have both. So you can have a data center in the Americas, data center in Europe, and data center in Africa. And you can work with consistency per data center or global. And when we're talking, and later we'll talk about latency, it's good to keep in mind that latency is greatly impacted by these geographical distances, because the latency between such two data centers can get to 100 milliseconds easily. But if we're talking about the same data center or even the same zone, it's sub-millisecond. So when you build in your application, often you will set up your driver to work in a local quorum, so your both read and writes doesn't have to wait for the latency between, and point to the screen, between the data center. The application can only wait for the latency in the data center. So you get both the global replication, but also the very low latency. And this was sadly proved by fire, I think a year ago, or even a little bit more than that, that one of our customers actually had one of his data center completely burned down. As far as I know, no one was hurt, luckily. But as you can see in our monitoring, the cluster continued to work because it have a deployment of 3 data center, 10 server on each data center, and this 10 server, of course, is down, but the rest of the cluster just continued to work smoothly. So that was the part with, I briefly introduced Scylla, where it's mapped to the NoSQL database. It's a distributed database. But now I want to deep dive into what makes Scylla less expensive for you. And there are 3 main factors in this equation. One, which I guess we spend most of the time on, is higher throughput. And I will explain both why it can save you money, but also how we got to a higher throughput. Lower consistent latency, I will cover that as well, and easier administration. Probably that's going to be the shortest path. So why higher throughput translates to lower cost? It's pretty straightforward. Let's imagine that you have, and I will demonstrate it later, let's imagine that you have a Apache Cassandra deployment of a 24 machine. By moving to Scylla and having each of these server work 10 times as fast, you can simply reduce the number of servers by the factor of 10 or close to it, and still handle the same amount of capacity or throughput. So this immediately translates to great saving. And as you know, in the cloud, it's a very dynamic environment, and it's very easy to get into bill in spiral and pay a lot of money, but this is a quick way to reduce your cost. Now, more than that, Scylla was designed, and I will talk about it a little bit later, was designed with multi-core deployment from scratch. So if you want to, you can switch to fewer number of servers, larger servers multi-core. This, by the way, sometimes would not immediately save you cost, because in AWS or EC2, usually the size and the price are proportional. So you get a bigger server with more storage, but it's also more expensive. But it will sometimes help you to manage the cluster and save administration cost, which was the third factor that I mentioned before, if you can remember. So again, higher throughput, less hardware, lower cost of operation. It's a very simple math. And here is some of the numbers to prove this point. So in this case, we compared ScyllaDB to Apache Cassandra, which is a great database. We took a lot of the basic algorithm from there and the API, but the implementation is completely built from scratch with performance in mind. So here you can see different workload that we tested Scylla with, different ratio between read and writes. And the bottom line is that Scylla perform much better than Apache Cassandra. You can see that Apache Cassandra is moving forward as well. Cassandra 4 is better than Cassandra 3, but still the Scylla throughput is much higher. And as I explained earlier, higher throughput, less hardware, lower cost. And this is how this lower cost translates with a similar kind of workload ratio between read and write, how it translates to less, basically less cost. Of course, in DynamoDB and Bigtable on Google, you don't really count the number of servers or anything like that, but you can and you should compare the price that you pay per workload. As you can see, if you compare Scylla to DynamoDB, for example, in this use case, you have 1/5 of the cost of DynamoDB. And by the way, I had just in the last Scylla Summit, I had a full session just comparing ScyllaDB to DynamoDB. So if you are interested in enhancement on this slide, you can go back to the recording. But we also compare Scylla to Cassandra and we compare Scylla to Google Bigtable. And for each of those, the higher throughput translate immediately for lower cost. So Scylla, less expensive than any of this alternative and by much. A second factor, which is a little bit maybe tricky to grasp, is a lower consistency, and why it can be translated in some cases to higher revenue. So of course, this depends on your domain and your application. You might write an application which latency is completely irrelevant for, so this might not apply to you. But on many cases, and I brought here a few captures from different blogs and websites that cover this, lower latency actually translate immediately to higher revenue. And you can think in some industries, it's straightforward. So if you think, for example, on things like algo trading or ad tech with all the bids for the ads in different sites, of course, latency translates immediately to revenue, but also in domain like IoT, when you have a lot of reports going to the same machine, latency is also critical, and other domains. So I hope I established the fact that a lower latency can, in some cases, maybe in your cases, be translated to higher revenue. I want to dive a little bit deeper on that and explain why we're talking about tail latency, or sometimes we call it P99 latency. So for some naive, or I was such a naive person a few years back, I was mostly look at average number or mean number of each metrics. But in latency, it's very popular or more useful to look at the P99. And why is that? Two main reasons. So one reason that sometimes one application, especially if it's a complex game or a social application, every view or every action that you take on the application actually translate to many API calls, which in turn can be translated to many database calls. So easily one click on the button on a game or on a Discord chat or whatever can be translated to hundreds and hundreds of DB calls. Of course, you can try to optimize it, but sometimes it's not worth the effort. And if building such a view on a mobile game take hundreds of or 10 or 100 of DB calls, then clearly the slowest call will determine how fast the application is. Of course, you can try to mediate it, build your application in a better way, but often that's the case. And this is why the slowest 1% of the request is very important. The second reason that sometimes people miss is the fact that in many of the microservices on the way or the application on the way, the concurrency is limited. So if, for example, you only have 10 working threads in one of the applications on the way, and one of these threads is waiting for the database, and this database, which is not Scylla, get a garbage collection or something like that and have to wait for a second. It's not just that this request is very slow and as a result the P99 is bad. It's much worse because all the requests that are waiting behind this request on the queue are also get delayed. So the P99 latency of one request caused like a train wreck of slowness of the entire system. Of course, you can try to overcome it by adding parallelism or adding thread on some applications. Sometimes it's possible, sometimes it's not as trivial. And this is an example from one of our customers that compare, in this case, Apache Cassandra to Scylla. Here we see the actual P99 of the two applications. And this is not surprising because Scylla was built from scratch with latency in mind. Cassandra, as I mentioned, great database, but was built on the JVM without this kind of consideration. So the latency is not just much lower, especially the P99, it's also very, very consistent. And again, by design, by both databases. This is another benchmark that we took with Apache Cassandra 4.0, which is not the latest, by the way. There is now 4.1 and the previous release of Scylla. And here we try, this is actually combining, this graph combining both throughput and latency. The y-axis here, I'm not sure you can see my mouse pointer, but the y-axis is the latency. Note that it's a logarithmic graph, starting with 1 millisecond, then 5 milliseconds and such. And the x-axis is the throughput. So we're injecting more and more throughput into the cluster. At some point, the latency starts to grow on all databases. All systems are limited. But as you can see, the red and yellow graphs here, Cassandra at a very low, relatively low throughput, the latency starts to grow and the cluster is simply overloaded, while on Scylla, you can push a lot and a lot of throughput, much higher throughput into the system and still get pretty steady and low latency, below 5 milliseconds for the P99 for almost all the throughput. So low consistent latency. I mentioned earlier that Scylla is compatible with both Cassandra and DynamoDB. This is a DynamoDB use case. So we compare the same throughput, 100K of requests per second in both DynamoDB and Scylla Cloud. As you can see here, the latency in Scylla Cloud is much lower, especially the P99 latency. Again, P99 is where Scylla excel. But also if you compare the cost, and that is a result of the higher throughput that Scylla support, the cost with Scylla is of course lower and lower by much. So in DynamoDB, sometimes if you just started and you don't have a lot of requests per second, DynamoDB look like a good solution. But if you need the lower latency, higher throughput, and you don't have maybe hundreds of thousands of dollars to spare, you should look at ScyllaDB. And also I want to give a pointer here to a calculator that we built that compare the price between different scenarios of ScyllaDB and DynamoDB. Of course, you shouldn't take our word for it, and you should just compare it for yourself, do your measurement, and compare the result. So I already mentioned two factors of the lower cost. One is the higher throughput, second is the lower latency. The last topic I want to touch on in the cost perspective is less complexity. So why is a Scylla deployment can be less complex than other deployment? First, going back to the lower number of servers. If you need to manage 3 servers instead of 20 servers, very likely it will be simpler. And not by much, by the way, if you have good infrastructure and I don't know, using Terraform, Ansible, or what's not, you can maybe overcome this limitation. Another point of reducing complexity is the fact that Scylla is not based on the JVM. If you're familiar with JVM tuning, raise your hand. Okay, I cannot really see you, but I assume a few of you raise your hand. So JVM tuning is partially black magic, partially expertise. But as you know, it's pretty hard to do right, and it's changed over time with the workload. Luckily for us, Scylla was not built with the JVM, so you don't have to know all of this tuning. This is a specific slide about doing cluster management operation with Scylla. Scylla works faster than, for example, than Apache, comparing to Apache Cassandra. When you replace a node, then it's a stream to data from node to node. So all of these factors make administration easier. In addition to that, Scylla have a set of internal schedulers that I probably won't deep dive into, but it's reduced the number of configuration parameter and configurations that you need to do in general on database. So overall, a much simpler database to manage. And the last thing regarding simplicity or easy to manage is, of course, Scylla Cloud. Like other vendors, we offer Scylla as a managed service on the cloud. And of course, if you use that, it's much easier to manage, or to put it in other words, we are managing it for you. So you don't care if it's easy or hard. I explained why Scylla is less expensive than other databases: higher throughput, less hardware, lower cost, lower consistent latency, higher revenue, and easier administration. Maybe can give you better sleep at night. The second part of this presentation going to be a little bit on why or how we achieve such a better performance and higher throughput, etc. Let me quickly check if there is any relevant questions. Okay, I see a question about C-star. I will cover it in a second. So before we jump to the next session, which of the parameters that or the access that we mentioned earlier is more important to you? Higher throughput, lower latency, or easier administration? I will give you a few seconds to response. By the way, I think the response is very much dependent on your position in the organization. If you are maybe the CFO, you care about higher revenue. If you paying the bill for DynamoDB, you might care about the cost, etc. But it will be interesting to collect the information. Okay, so how did we create Scylla in such an effective way? So a brief trip in memory lane. I promise you it will be a very quick history lesson. So as you know, by the way, Moore from Intel just passed away a few weeks back. So you all, I'm sure you all know about the law of doubling the number of transistors on chip. But as you also probably know, this rule got flattened in the last few years, and you cannot actually make the cores more and more powerful. Instead, what vendors are doing is adding more and more core to the same machine. So if in the past we've seen a machine with 2 cores, 3 cores, now 64 core and such is more common. Another change that comes with this multiple core architecture is a non-uniform memory access. Each CPU have a closer chunk of memory that it can work with. Also, other updates in the last 10, 20 years, of course, much faster and much bigger storage. Usually you will use Scylla with NVMe storage. So Scylla was designed from scratch to handle it. Higher network throughput, much better I/O, more cores. So a lot of changes that are accumulating in the last few years, and Scylla was designed from scratch to take advantage of all of this hardware. So from the beginning, it was built to handle a multi-core deployment, fast storage, fast network and such. And this is how we achieved the great performance that I demonstrated earlier. A few design decisions that was made back in the day, about 7 or 8 years ago when Scylla we started to build Scylla. So first of all, build Scylla with C++. I know there is a lot of religious war, I would call it, between Java, C++, and maybe Rust and other languages. I don't think that moving from Java to C++ by itself will necessarily give you performance boost. The question is, what are you doing with C++ or any other languages? And with C++, you can, for example, control the memory in a more efficient way if you want to. And we did want to take control of that, so this is why we skipped to it. A second important principle is we treat everything in the code as asynchronic. So it's common to use network messaging as asynchronic, but in Scylla we also use I/O in a completely asynchronic way to get much better performance out of the storage. Shard per core architecture is probably the main or the number one principle that we took for high performance. So in some application, not just databases, in many other applications, there is many threads running on a limited number of cores. And these threads are competing with each other, both for CPU, but also for memory. So if two threads want to access the same memory area, they will have to lock until one is free. So there is a lot of CPU and ticks wasted on thread competing for resources. In Scylla, we completely got rid of that. We have one thread per core, or a shard as we call it. And this thread have a dedicated chunk of memory. If you remember the NUMA architecture, it will be a chunk closer to the CPU. It's have its own chunk of the file system and of course its own core. So threads are not competing with each other. And if two threads do want to share information, they do it in a message passing way, which is super efficient. And by the way, this everything that we see here is composed or cooked into what we call the C-Star framework that I've been asked about before. C-Star is an open source library in C++ that we developed that allow you to build high performance application. It's used by Scylla, but by other applications as well. Red Panda is one, but there are many other. You can check it out. Quickly, a few other design decisions that we made in Scylla. One is to use unified cache and skip the Linux page cache altogether. Using the Linux page cache is usually a bad idea for databases, and I highly recommend this paper from Andy Pavlo and other. By the way, let me plug in, there is a great course by Andy available on YouTube on distributed database, or database in general, sorry. Look it up, I learned a lot from it. But the slide with Robin and Batman is my own. Another design decision that we took on Scylla is taking advantage of the storage in a smart way, meaning first measuring the sweet spot of the storage and then try not to overload it with too many concurrent requests. And last, I think I mentioned that earlier, scheduler that allow us to control and give the right priority to different processes that are running on the database. And there is more than one. There are read requests, write requests, offline requests like compaction and others. This is, by the way, from our latest Scylla version. We have a more complex storage bandwidth measurement that allow us to, again, to find the sweet spot of the storage, not just in terms of number of requests per second, but also bandwidth of read, bandwidth of write. Different storage might have different sweet spots. And with the latest instance type from EC2, the I4I, the fact that Scylla was designed from scratch to work with the latest hardware, every time there is a new generation of servers on EC2, we immediately can test it and usually get much better result, because we do, or not we, Scylla, immediately take advantage of all the multiple core and the great storage and just run faster. And it's again both for AWS and EC2 and for us and for our users. And if the brief introduction to latency design or performance design is relevant to you, I highly recommend check out the P99 conference. It's a conference that we help organize every year. And there is actually a call for paper, a call for presentation for the upcoming event in October. But if you go back to previous years and look at the videos, there are many interesting videos there about latency from Gil Tene and other. Highly recommended, very, very technical deep dive there. Okay, the last topic I'm going to touch on is workload prioritization. Workload prioritization is a feature that earlier I saw the scheduling mechanism that allows Scylla to work. We expose some of this scheduling property as API for the user, and why is it relevant? In the previous slide, I mentioned that low latency is preferable for many domains, but in some cases, the same user or the same customer have at least two kinds of workload, one which is latency sensitive and one which is not latency sensitive. And two typical example will be what is called OLTP and OLAP, when the OLTP is a real-time part. The T is actually transaction, but the OLTP is online transaction, which latency is critical. Let's say that you need a sub-millisecond for your real-time request, both read and write. It's an OLTP workload, but you also have an analytic workload that, for example, run every hour and can run 10 minutes or 1 minute, or I don't know, you don't really care, because it's something that scans a lot of data and latency is less relevant. So Scylla allow you to run both workload. I guess many databases allow you to work both workload, but in Scylla you can actually control how much shares of the resources each of these workloads get. And the idea is to guarantee that the real-time request will get higher number of share and will return the result in a sub-millisecond fashion, while the analytic workload can work a little bit slower and you don't really care. So you can control using a feature called workload prioritization, which is limited to Scylla Enterprise, how many share of resources you want to give to each of these workload. As long as the system is not fully utilized, this share doesn't mean anything. Scylla will try to give all the relevant resources to both workloads. But as soon as the workload are close to 100%, so you don't have enough to give both of them, Scylla will prioritize the real-time request first and only give 10%, for example, for the analytic workload. So this is a very useful feature, and it can actually save you money in the theme of this session, because before we had this feature, what customer would do is they have one data center for real-time, one data center for analytics. Sometimes with different type of storage or instance type. So with workload prioritization, you don't need to duplicate your hardware just to run two different workloads. You can actually run them on the same data center or the same deployment. Using the workload prioritization, guarantee that the runtime or real-time will get more shares. And by the way, the analytic versus real-time is just one example of workload prioritization. There are many other cases. You want to give two workloads or three workloads the same number of share or different ratio. It's really dependent on your business logic. I will skip to how does it work and try to summarize what we've seen so far. I try to demonstrate why Scylla can be less expensive than other databases and actually increase your revenue. And this is a few examples from our customer, at least the public information that they're willing to share, of how they reduce cost with Scylla. So in this case, Comcast migrate from Apache Cassandra to Scylla and reduce the number of nodes significantly, as you can see here. We have a lot of streaming customers because latency and high throughput is relevant there. So Disney also use Scylla to reduce cost. I'm running a little bit faster because we don't have time for all the example, but many of our customers use Scylla to reduce cost in many different domains. So since video streaming to security to operation, IoT, and many other examples. And I'm mentioning here Discord because they just published a very detailed blog post that you can check out about the migration from, I think, originally from MongoDB, then Apache Cassandra, then ScyllaDB. Of course, Discord run a huge operation, so they have a lot of requests per second, a lot of requests in general, so a significant deployment. And to summarize, ScyllaDB is compatible with both Apache Cassandra and DynamoDB. So if you're using either of them, you can easily switch to Scylla. But also, if you're using any other database and want to reduce cost, Scylla might be a good alternative for you. Scylla is less expensive because it's have a higher throughput, as you remember, and have a lower or has lower tail latency or lower latency in general. And the last bullet I actually didn't mention, so it's not really a summary, but a point I want to clarify. You can migrate, and we have tooling for migrating from other databases to Scylla without downtime. So if you want to try Scylla and you want to migrate your production data, there are tooling to do that, and we can help you achieve this goal. That's basically it. Scylla is less expensive, higher throughput, and easier to maintain than other database. And if you have any question at this point, I will be happy to answer them. So let's switch to the question here. Okay, I already answered the sister question. The second question that I see here regarding drivers. I mentioned that Scylla is compatible both with Apache Cassandra and DynamoDB, and that's means that you can just use a driver for either DynamoDB and Apache Cassandra to work with Scylla. But if you're using the CQL API, Scylla forked a few of the major driver of Apache Cassandra and added a few features there that make performance even higher. So if, for example, you're using Java, Python, C++, Rust, PHP, and maybe a few more, check out if there is actually a Scylla fork for all of this driver, and it will give you performance gain on top of the Apache Cassandra driver, mostly through a feature called a core-sensitive distribution, but it's not part of this session, so I don't want to dive into it. Second question that I see, can you run Scylla locally? I'm rewording it, and please correct me if I'm wrong. Can you run Scylla locally with Docker? So yes, of course you can do that, like any other application, but you need to be careful because out of the box, Docker configuration does not take advantage of the hardware in an efficient way. So if you look at the doc, look for in Scylla docs for best practice for running with Docker. And if you follow this best practice closely, you can get to a very close performance to working directly on the VM. And we actually test it quite heavily because it's run our cloud serverless and other services. So we know for a fact that you can get performance on Docker which are very close to the VM, but it's not the default. So if you just run the default, you wouldn't get such a good result. Also, there is a common mistake of people try to do benchmark on their own laptop, running both the database, whatever database, running both the database and the loader or the stress on the same laptop when doing a benchmark. The results are completely random because the loader and the database competing for the same resources. So it's far away from a production environment. So be careful when you do performance tests, not just for databases, it's general recommendation. What would you recommend running Scylla on? Kubernetes or VM directly? VM directly is definitely simpler in a sense that if you're working, for example, on EC2 or Google or Azure, you can just take the pre-cooked image, AMI as they call it on EC2, and just run it. You have if you look in the community AMI for Scylla, you will find the latest version, 5.1, and you can just use that. You can run, as I mentioned, Scylla on Kubernetes. We have an open source operator that you should check out, but it requires some more administration and some more work at this point. We are working to make it smoother and smoother, so it will be easier. Okay, 2 more questions. Let me drink some water first. Is there a migration path from Scylla to Scylla, sorry, from MongoDB? So yes and no. Yes, of course, you can migrate from any database to any database, and many people actually do or did migrate from Mongo to Scylla, mostly because of performance and scaling issue. But keep in mind that it's 2 different data modeling. So MongoDB is a document-based database. ScyllaDB is a wide column database with a schema. So it's not that you can take your application as is, point it to Scylla, and it would start work as you would expect from Cassandra or DynamoDB, which are compatible. Well, moving from MongoDB to Scylla will require you to define the new schema, all the table that you might need, migrate the data, maybe do some transformation in the middle, and only then you can work with the data. But it's been done, it's doable, and our solution team collected a lot of experience in that area. So if you're interested, we can help you. Are there cases where ScyllaDB may not be the best choice? For sure, no one solution is good for all cases. ScyllaDB excel in highly available big data and high performance use case. But if that's not the use case for you, and I will give you an example, let's say that you only have 1,000 requests per second and only a few gigabytes of data. If this is what you have and you are not expected to grow much more than that, maybe a distributed database is not what you need, and you can use, I don't know, MySQL or something running on your laptop. It will be good enough. At some point, if you have 10 of thousands or hundreds of thousands, or you expect to get to 1 million requests per second, then Scylla is a much, much better choice. But if you don't expect to get to such high throughput and such, Scylla might be not relevant. Another use case where Scylla is less of Scylla sweet spot is analytics. I mentioned earlier that Scylla is very good in running real-time analytics on the same server. But if all you have is analytics, then databases like Snowflakes might be a better choice for you because they handle better ad hoc requests. And in analytics, in many cases, there is no real-time request that you need a quick response for. Rather, each BI person create his own ad hoc queries, and they're changed every minute or something like that. So this is a different type of database when you care less about latency and more about if it's take you a minute or 2 minutes or something like that. In Scylla, the sweet spot is requests where you expect it sub-millisecond or close to his request. And last question as I see, the current ScyllaDB instance setup is over-engineered. It's hard to say. I don't have a quick answer for that, but you can check in the Scylla monitoring. We have a Scylla monitoring open source platform just to monitor Scylla. You can check it out. And I will look there for the number of requests per second, the load on each shard, and the number of requests for the storage. If all of these parameters are way below 10%, maybe you can reduce the size of your deployment. So the question about Futurama, no, I hope it doesn't look similar to the brain slug. But now that you say it, I can see the resemblance, but it was not modeled after it. Okay, so thank you very much. I hope you enjoyed the session. And by the way, if you have more questions, you can jump into the Scylla forum or the Scylla Slack channel. I will be there for the next hour. And if I'm not, other people smarter than me will be there to answer your question. So thank you very much.